All right, so let's look at this in another way. Sometimes it's hard to picture these waves combining, so let's think of them a little bit more by graphing the amplitude of the wave and seeing how we can have this constructive interference. So again, if we think of a graph of the wave function, we have the wave function is at its highest amplitude when it's lined up with the nucleus, and then as we get further away from the nucleus, the amplitude of the wave function ends up tapering off until it never hits 0 exactly, but it goes down very low. So we can draw that for 1SA. We can also draw it for 1SB. And what I'm saying for the molecular wave function is that we have the interference between the two, and we have a constructive interference. So we end up adding these two wave functions together. So we're talking about wave functions, and we know that means orbitals. But this is probably the better way to think about it is the physical interpretation of the wave function. So what is the wave function squared going to be equal to? Probability density, yes. Probability density of finding an electron within that molecule in some given volume. So let's think about that instead. Let's think about probability density. So if we're talking about probability density, that's the wave function squared. But now we're talking not about an atomic wave function, we're talking about a molecular wave function. So to talk about it squared, we're going to say it's sigma 1s squared. Oh, and actually, before you skip your page on the notes, I realized I should write out for you what the addition is to start with. So when we're combining two waves, what we have is 1sa that we're adding together with 1s for B, the second atom. And what we end up for our molecular wave function is sigma 1s. So this is what we call our molecular orbital. All right, so that will now allow you to turn the page, I think. And we can take a look at the probability. So the probability, again, that's just the orbital squared, the wave function squared. So when we write that out, we just write sigma 1s squared. Or we can break it up into its individual parts. There's no reason we can't do that as well. So just to say that it's 1s squared plus 1sb, all of that together squared. So if we write out every term individually, what we end up with is essentially just the probability density for the first atom, then the probability density for the second atom, and then we have this last term here, and this is what ends up being the interference term. So in this case, where we're adding it together, this is going to be constructive interference. So in this case, the cross term represents constructive interference between the two 1s atomic wave functions. And this, again, is what we're going to call a bonding orbital.